Hi everybody. In this video, we are going to see about the DCV and FCV. What is the DCV and FCV? Directional control valves and flow control valves. Okay. In the subject mechatronics, we are discussing about the actuators and the directional control valves. Mechanical actuation we have seen, electrical actuation seen in the previous videos. Now we are going for the direct control valves and flow control valves. What is that? Direct control valve, direction control valve is the direction. So the in which way the water or the liquid or the fluid has to flow. So a valve is going to decide the direction, or it guides the direction of the fluid and to the actuator, right? So flow control valve is the one which guides with flow, the amount of flow. So if we want to supply more amount of fluid, or if you want to go for a less amount of fluid according to the load conditions, then the amount of flow of fluid is needed to be controlled. So for that purpose, this flow control valves, the FL FCV, also going to be used. So in the direction control valves, we have called as, we are having ports, and the ports are the ways which are going to get. So the four ports, if they are there, it is called four-way ports and four-way valve. And flow control valve, it's as I said, it's responsible for the speed of the actuator. When we want to move the actuator in a much faster speed, we will give more amount of fluid, so that flow, how much it is needed, the speed of the actuator can be controlled with more fluid or less fluid with the help of control valves, right? So there are some the classifications of the valves. Let me see some classification, the type of construction, the principle, how it is constructed. So one is puppet valve and a spool valve. It depends upon the construction. We call it as puppet valves and spool valves. And the number of ports. So how many number of way? That way is a port, I said. So number of ports, either two-way valve or three-way valve or four-way valves. Okay, we will see one by one in the next further videos. So next, number of switching position, two position or three position, how the position of the valve can be located, either two or three positions. And actuating mechanism, this is one important thing, is how the valves are going to be actuated. Manual actuated, no, only the through manpower we can use the levers. We can use this manual actuation method. A mechanical actuation system is there, okay, with the help of cams and all we can use it. And solenoid actuation. So solenoid, in the last video we have studied about what is a solenoid and what is a relay in the electrical system. So solenoid is a device which is having a coil of wire, okay, coil, and with a piston with a plunger, okay, movable inside. So it is wound, a plunger is wounded over a coil of wire. So when a power supply is given to the coil, the electromagnetic field is going to be produced, and it moves the plunger in. So that by using that action, we can control the flow of valve, okay, the flow of liquids. So that also can be done. The flow of liquids can be done with the solenoid actuation, and through direct through hydraulic actuation, and through pneumatic actuation it can be operated. So like this, the actuation mechanism is also decides the valve functions. And now that's what here we are going to see, that mechanical actuation system, in the sense what are all the things we are going to use is roller and cam, okay. Normal cams are used, we have discussed about the previous mechanical actuation system. We have studied the gears, cams, rollers, rack and pinion movements and all. These also will be used for the control the movement of the slides inside that, for the direction control or spool. The direction control or flow control valves, we have to activate the mechanism. So here the mechanical actuation system, the plunger or cam or gear rack is gears are attached to the actuator. thus it will help to control the flow. Okay, so this is what a mechanical actuation system. And the solenoid actuation is energized solenoid coil creates a magnetic field so that the plunger can be moved, and this can help us for the actuation of these control valves. So here one example we can see this unidirectional valve, and it's controlled with the help of the spring on the ball is getting seated on the path. So when the liquid is there coming over the bottom, there is a path where the flow is allowed. When it is attached to the pump, it's normally in the delivery sorry, in the suction pipe, a flow check valve will be there, that is one directional valve. When water enters or liquid enters through this flow allowed area, it pushes the ball, and which is already it is fitted with the spring. Okay, since the due to the spring pressure, with the help of some predetermined spring pressure, the ball is getting locked seated in this valve seat. Okay, so when a fluid with some pressure comes in, it pushes the ball up the against the spring force, and it moves upward. But in the same time, if the flow comes from the top, it won't allow to go inside. So it's allowed only one way side, one direction side. So we call it as a unidirectional valve. So, and it's a ball type valve. Suppose in case in this case you can see one more Papat valve. Papat valve is a where a membrane closing member is not a ball, but it is a puppet energized by the spring, and it is seated on the gap. Okay, so when the force is required to flow up, it flow and it pushes the wall which is seated, the puppet which is already seated with the help of the spring force, then it allows to go. But in the reverse direction it won't go allow. And one more needle valve is also present here. So it's another kind of valve which is having the control of flow is also can be done with the same valve direction. The flow check valve is there, and as well as the how much amount of flow has to be done, then the adjustment of screw, it will decide the flow of liquids, right? And the pilot operated check valve is a pilot port is there. Direct force when this is the extra pressure given through the pilot line. So normally the flow normally blocked. Okay, if you see that puppet, movable puppet, normally it will be blocked because of the spring force. So fluid cannot move in a direction from the top to bottom. It won't allow the water or liquid to come down to this flow. But at the same time, if you want to stop the system, and we can go for the pilot operated pressure, so that the pilot pressure which here you can see this pilot pressure lifts the piston. Okay, here it will lift the piston, and it will pushes the spring up, so that here a gap is going to be produced, so that the fluid can move in both the direction. So that the fluid in the another direction, it makes a okay equal pressure, so that the both the side direction is going to be stopped. So in case of stopping the fluid flow from we can through the pipe through the pilot pressure, if you open that, and both the pressure are getting equalized at this point, so the pilot allows free flow in one direction and prevent the flow in the other direction until the pilot pressure is applied. So this is how the pilot operated check is a check valve is going to be operated. So by this way, this is the basic structure of constructions of the puppet valve and ball as a pilot operated check valve, and the ball type valve, the puppet valve, all we have seen in the first video. In the second video we are going to see about further classifications and the symbols and everything. Okay, thank you.